Hello everyone, welcome to the poster session of our paper Transform, Retrieve, Generate Natural Language-Centric Outside Knowledge Visual Question Answering. I'm Qing, one of the authors of the paper. This work is supported by UCLA and Amazon Alexa AI. OKVQA is different from classic VQA or knowledge-based VQA. It requires answering the question not only based on the image, but also external knowledge. Any knowledge available on the World Wide Web will be used. OKVQA is very challenging. First, it cannot be answered only with the image. Second, outside knowledge base could be huge and we don't have any assumption of the knowledge-based representation. In addition, we don't have the ground truth knowledge to a specific image question pair. Lastly, it is multimodal alignment. Some existing work have proposed different solutions to the OKVQA problem. Most previous work relies on multimodal alignment, which are pre-trained on visual language datasets. Most of these datasets are visually descriptive. However, for visual reasoning tasks such as OKVQA, the model needs to learn beyond visual descriptive alignment and learn to reason in abstract semantic space. Previous work also formulated the task as a classification or span prediction task, which may be inflexible for open vocabulary tasks such as OKVQA. We propose to formulate as a generative task instead. In this paper, we propose to map the image into text first and then perform knowledge retrieval and question answering all in the text modality. We propose the Transform, Retrieve, Generate framework to tackle the OKVQA problem. The key idea of our framework is to use natural language as the unified representation. This enables retrieval from large-scale corpus. Meanwhile, it leverages the semantically rich pre-trained language models. In the first stage, we use a three-level transformation to transform image to text. It includes image captioning by OSCA, dense labeling by WinVL, and OCR modules. In the second stage, we use the generated caption together with the question as the query to retrieve knowledge passages from Wikipedia. We use two BERT encoders respectively to encode the query and the knowledge passage. By calculating the similarity score with dot product, we can retrieve semantically related knowledge passages. In the third stage, we propose a generative multi-passage QA model for question answering. Each question, together with its visual context from stage 1, will be appended to one retrieved passage from Wikipedia. We use a pre-trained transformer-based model T5 to encode the K of these encoded passages. Later, we concatenate these K embeddings and use a T5 decoder to generate the answer. We use the exact match and VQA score to evaluate our model performance. We compare it with two sets of cutting-edge models. First, we compare with supervised learning SOTAs, where we observe that our trick model significantly outperforms the baseline by even 11.1%. Second, we compare with the prompt-based SOTA measures. We also observe a 2.5% improvement over Pika, given the fact that the size of Pika model is 200 times larger than our model. We further did an ablation study with an increasing number of K passages and see how it impacts our knowledge retrieval and question answering. We observe a consistent pattern that as K increases, we are more likely to retrieve knowledge that contain the correct answer. Moreover, as K increases, the QA model is more likely to predict the correct answer. We also perform error analysis by manually classifying 50 wrong predictions and summarizing the root causes. We observe that 50% of the error is due to image-to-text transformation, followed by wrong annotation, failure of retrieval, and failure of QA model. To see more correct and incorrect prediction examples, please check our paper. Thank you for watching.